All right, here we go. 2.12. This is going to go by pretty quickly. So again, ask me to slow down if we need to. But a lot of these properties we just covered in 2.9 already, right? With some various different problems. So I'm not going to cover product, quotient, or power property again. We should be pretty good here already. Okay. So again, just applying the properties themselves to condensed log. So we might give you a few problems where you start with a whole bunch of logs, and I only want one log in the end as my final expression. So clearly, these two logs are adding. I can apply the product rule and rewrite it as log base 4 of xy. Here's part B. These two logs are subtracting. Log base 3 of 5 over z. Part C, there's 3 different logs, but again, just go from left to right and then do whatever properties you can do. Ideally, you tend to go in this pattern. I tend to do power first and then product or quotient. Right? There's no power rules here at all, so it just seems like I'll do the quotient rule here first. So I'll say log base 10 of x over 5 minus log base 10 of z. I can apply the quotient rule. What's up?
Can you make it so that like we can fully see the screen?
Oh, my bad. I did not know. We're good now, though? My bad. I did not realize I did that. And here, I would do the quotient rule one more time and say log base 10 of x over 5z. If you're curious on how that just happened, if you were to take x divided by 5 and divide by z, do keep, change, and flip, and you'll get the same result. Let's move on to part D here. Notice now I can do the product rule for the first log. I'll rewrite that as log base 2 of x cubed minus log base 2 of y. And then I'll apply the quotient rule and say log base 2 of x cubed divided by y. Here's part E, where there's 3 different logs, but all right, here's part E. So again, we try ideally do the product rule first, right? The power rule first, and apply any products or quotients again from left to right. So for the first 2 logs, I'll do the power rule. That's log base 7 of a squared minus log base 7 of b to the power of 5 plus log base 7 of 4. And then I'll apply the quotient rule for the first 2 logs. That's log base 7 of a squared divided by b to the power of 5, all plus log base 7 of 4. Then these 2 logs are adding, so I'll do the product rule. So log base 7 of 4a squared divided by b to the power of 5. And that's it. That's the final answer. All right, here's part F. This one requires a little bit of creativity. I see a constant and a log, and I really don't combine right now using any of our log rules because it requires this to also be a log. But technically, I could rewrite it into a log. Creatively, I can rewrite this as log base 6 of 6 squared. Take a second, and do you agree with why I would do something like that? Because it's still the same thing as 2. Let me put a star by this one so you can recall to that specific scale that might help you with any particular problem like this. And now that the bases are the same, I can actually do the properties with these 2 logs. So really I have log base 6 of 36x. Okay, let's continue. Which of the following expressions is equivalent to log base 3 of x squared divided by y? Nope, I'm going to continue. So in this case, we want to take this log and expand. And so we'll take some time and see which rules we can undo. I see 2 things are dividing, so I'll do the quotient rule first. I have log base 3 of x squared minus log base 3 of y. And then I notice with the first log that it has a power, which I can also undo. I'll do the power rule here. We'll take that power and move it as the coefficient of that log. 2 log base 3 of x minus log base 3 of y. And I think that does match one of my answer choices. It's going to be C. Now I'll go back. Which one do you want me to go back to?
Just one right before F.
Okay. All right, let's go to example number 3. The function f of x is equal to log of 6x is a horizontal dilation, right? There's a 6 being multiplied to x. And then the function g of x is equal to log of x, right? So they're saying that's the original function, and this one is a dilation of that original function. Show that f can be written as a vertical translation of g, with f of x is equal to g of x plus k. So all we're saying is, can I rewrite this horizontal dilation instead as a vertical translation, right? The same concept occurred with our exponentials, where a shift left or right in exponential, I'll rewrite it like x plus 3. That was the same thing as saying, what is that, 8 times 2 to the x, right? Those were equivalent statements. So we're kind of repeating the same idea here. But we'll be careful with the correct math jargon they gave us. So they're saying, how can I rewrite it in this form? G of x plus k. So ideally, I have some f of x here equals to log of x plus some k. I don't know what k is. I got to figure out what that is. So to figure out what that is, I'm just going to undo the product rule here to this function. So I get f of x is equals to log of 6 plus log of x. I pretty much have it in this form. I have the log of x. It's right there. The constant k just so happens to be log of 6. So k is equals to 6. Sorry, not 6. Log of 6. And so if I wanted to be really, really concise with the formatting that they have, I might just move log of x in front and then log of 6 in the back. So I've proven the statement and the structure that they want it to be in. This is f of x. Sorry, this is g of x plus k, and k is labeled. And so we're all done. How do we know that k is the constant?
No. How do we know that log of 6 is our, how do we know that that's our constant?
Because there's no variable. There's no variable. Like this is a number. I don't know what number that is, but it's a number. It's a constant. Like g of x is log of x. K would have to be the constant. I'd be more than happy to address this individually. We can keep going. Okay? All right. The change of base property. So we're going to go more deliberately with this formula here and use it in this example. So we've already covered it, so maybe let's just apply it here. They claim that f of x is equals to log base 4 of x, and g of x is equal to log base 9 of x. What do we want to prove? Let's show that f is a vertical dilation of g by finding the value of k, where k this time is the coefficient of g of x. So maybe I'll just plug in what I know right now. F of x is equals to k times log base 9 of x. I'm hoping that I can go from here and get to here. Okay, that's the whole goal of the problem. Do we agree from where we start we have a different base? So we probably should use a change of base formula to get to the base of 9. Let's do that and see if it kind of works out the problem for us. Okay, so let's do some scratch work, and ideally this works out. So let's say f of x, well, I'll just say log base 4 of x. Log base 4 of x. This can be rewritten as a base of 9, where the x goes on top, and then the 4 goes on bottom. So all I do is apply the change of base formula to what f of x is to be base 9. And then here, I'm pretty much almost done. This next step might feel really weird, but it's going to be the same thing as this, okay? If I ever said x over 2, do you guys agree that's simply just 1/2 x? The same idea applies here. This can be rewritten as 1 over log base 9 of 4 times log base 9 of x. It's the same thing. And if you look now, I think what we have in our answer so far is in the exact formatting that I want f of x to be in. Some k value in front that's multiplying to log base 9 of x. So k is equals to what? Let's see. K is equals to 1 over log base 9 of 4. Any questions about this problem? Yes, sir.
How do we get it to 1 over log base A4?
Are you okay with x over 2 being equal to 1/2 x?
Yeah.
Same thing applies here. That's just 1 over log base 9 of 4. Like if I move this, is this not just 1 over log base 9 of 4?
Wait, so is log base 4 of x equal to 1?
No.
I guess I just want to see how they relate.
Like you don't see how we get from here to here.
No.
But you're okay with this though?
Yeah.
Okay. Then in theory, are you okay if I was to erase this, that's true?
What? To erase.
I'm saying this is its own number. I don't know what number that is, but the coefficient is 1. If I got rid of it, that's just 1 over log base 9 of 4.
Oh, okay. Yeah, I understand.
And if I bring this, this is just multiplying.
Yeah, okay, okay, that makes sense.
Yeah? Okay.
Yeah.
All right, any other questions about this? All right, let's continue. All right, this should be the last problem in this section. The logarithm of base e is called a natural log. We've already talked about this. So pretty much we have this right here, and our answer choices are just equivalent forms. So let's try to condense this into one log, because our answer choices are in one log, and see which one is the same. So for each logs here, I can apply the power rule. I can rewrite this as natural log of x to the power of 3 minus natural log of y to the power of 4. And then I can apply the quotient rule and rewrite this as natural log of x cubed divided by y to the power of 4. And I believe that should be one of my answer choices. A. Alright, that finishes 2.12. Any questions about 2.12? Alright, good deal. Let me stop the recording.